and welcome. In our lesson today, we are going to discuss one of the factors that affect the rate of a reaction. Now, this, of course, is temperature. Now, when we talk about temperature, we know that temperature usually speeds up a chemical reaction. But what is the reason for this? Now, this is because that when you increase the temperature, what happens is that you increase the kinetic energy of the particles. Now, of course, kinetic energy is the energy that is responsible for movement of particles. So that means that the particles are going to move faster. This will increase the chances of effective collisions happening. Therefore, the rate of the reaction also increases. Now, what about if you decrease the temperature? If you decrease the temperature, then of course, you decrease the kinetic energy of the particles. Therefore, you reduce the chances of effective collisions happening. And therefore, the rate of the reaction decreases. Now, a very common example that is used for illustrating how temperature affects chemical reactions is that between sodium thiosulfate and hydrochloric acid. Now, sodium thiosulfate reacts with hydrochloric acid to form four products. So we have sodium chloride, we have water, sulfur 4 oxide, and lastly, sulfur. Now, what happens is that this question usually features in paper 3 of chemistry practical. So students are asked to draw a cross, an X on a piece of paper as such, and then take a beaker, place it above the cross. And then they're supposed to pour the two solutions in the beaker. Now, what happens is that both these solutions are colorless. So when you pour them in the beaker, they start reacting with one another. Now, this reaction leads to the formation of the following products, one of them being sulfur. Now, sulfur forms a yellow precipitate. Remember, sulfur is yellow in color and insoluble. So a precipitate is formed that is yellow in color. Now, you're supposed to look through the beaker, through the solutions to see the cross. So you're supposed to note the time it takes for the cross to become invisible. Now, if you're wondering, why will the cross be invisible? Remember, we are forming a yellow precipitate of sulfur, which will make it invisible at a point for you to see the cross. So you're supposed to note the time it takes for the cross to be invisible. Now, you'll note that when you have high temperatures, the time it takes for the cross to be invisible is very short, very little time. Why? Because an increase in temperature increases the rate of a reaction. So sulfur is formed at a very fast rate. But when you have low temperatures, the rate of the reaction is slowed down. So sulfur is still formed, but it takes a longer time. And that is that. Now let us tackle past KCSE questions on temperature to test our knowledge and also to see how questions come from this subtopic. This is our first question. It's from 2001, paper 1, and it goes as such. In an experiment, 0.8 grams of magnesium powder were reacted with excess dilute sulfuric acid at 25 degrees Celsius. The time for the reaction to come to completion was recorded. The experiment was repeated at 40 degrees Celsius. In which experiment was the time taken shorter? Explain your answer. So we have two sets of experiments. Now, in these experiments, we are using the same mass of magnesium powder, which is 0.8 grams. The only difference between these two is that one occurs at 25 degrees Celsius and the other at 40 degrees Celsius. We know that if you increase the temperature, what happens is that you're increasing the kinetic energy of the molecules, therefore increasing the chances of effective collisions, which also increases the rate of the reaction. So that means that experiment 2 will have a faster rate compared to experiment 1. Therefore, it will take the shorter time. Okay, let's try out another question. This is from 2008, paper 1. A certain mass of a metal E1 reacted with excess dilute hydrochloric acid at 25 degrees Celsius. The volume of hydrogen gas liberated was measured after every 30 seconds. The results were presented as shown in the graph below. Now we have a graph plotted below of volume of hydrogen gas in cubic centimeters against time in seconds. Part A. Name one piece of apparatus that may have been used to measure the volume of the gas liberated. So this is a reaction between a metal and an acid, which of course will lead to the formation of a salt and hydrogen gas. Now, if you want to find the exact volume of hydrogen gas collected, then you will need to do so in an apparatus that has graduations. Now, these are simply the markings that are there that will let you know the exact volume of the hydrogen gas collected. So this can either be a gas syringe or a graduated gas cylinder. B Roman 1, on the same axis, sketch the curve that will be obtained if the experiment was repeated at 35 degrees Celsius. So initially, the reaction took place at 25 degrees Celsius. Now, if the temperature was to be increased to 35 degrees Celsius, what will happen is that the rate of the reaction will be higher, will be faster. Now, this is because there will be more effective collisions as a result of a higher energy of the particles. So that means that when sketching the graph will be steeper because more hydrogen gas will be collected at a faster rate within a shorter time. So there we have our graph. So part 2, explain the shape of your curve in B Roman 1. So we've already done that. Now I want you to note something. Both curves flatten out at the same final volume. This means that the total volume of hydrogen gas collected for both reactions is going to be the same. The only difference is the time each reaction takes. Now the reason for this is because the mass of magnesium metal used in both reactions was the same. So we end up having the same volume of hydrogen gas collected at the end. And there we have it. So I hope that these questions have been enough to test your understanding of how temperature affects the rate of a reaction. I'll see you next time in our new video where I'll be discussing the effects of pressure. See you there.